And before we can go further, we also need to talk a little bit about a notation and operation of linear algebra objects. Now, I know that some of you may not have taken linear algebra. Some of you may have forgotten about it. In 2013 May, we will have a summer course, a version for this very course, where we will have no need for any linear algebra terminology. It is possible to talk about everything we are going to talk about without using the language of linear algebra. However, that discussion will take a much longer time, because without these shorthand notations we call vector and matrices, it would be very hard to explain every step, and a lot of the existing results from linear algebra concerning matrices we won't be able to use. So in the interest of time, we will have to then shrink the discussion to a much smaller subset of what we will be talking about in this course. So I just want to highlight that it is possible to talk about these things without the machinery of linear algebra, which we will indeed be doing in May 2013. But in this version of the course, we will be using linear algebra. Okay. It is a very useful shorthand notation plus a powerful set of machinery that will allow us to accelerate the discussion. Now I'll try to make this as non-linear algebraic as possible, but at some point we will have to do a little bit of that kind of math. Okay, so if you need to tune out, feel free, but you may still be able to get some of the interesting ideas, even though some mathematical operations may be beyond your understanding at this point. All right. So we have been using vector quite a lot, right? This vector pi is a vector, and by convention, a vector is a stacked up column. Okay, pi 1, pi 2, pi n. Say pi 100. Okay. And what's a matrix? Well, a matrix is really, in general, an object with, say, n rows and m columns. Okay. So we can think of that as many vectors arranged in parallel, or we can think of that as many rows stacked up. Okay, either way. Let's say we got a matrix A, then we can denote this matrix A's ijth entry as A sub ij. Okay. In all of the material that we will be talking about, this is just a real number. Could be positive, could be negative. In today's lecture, it is never negative. And sometimes we use a little arrow on top of a big letter to represent that it is a matrix. A matrix multiplying a vector is a funny operation, you may say. If matrix A, okay, multiplies a vector x, let's say matrix A is 2 by 2. Let's say it is 1, 3, 4, 2. Okay. And vector x is just x1, x2. What you get is the following. Okay. First of all, the matrix is 2 by 2. The vector is 2 by 1. So what you get is a 2 by 1 vector. The first entry is the inner product of the first row vector of the matrix and this vector x. So that is x1 plus 3 times x2. 1 times x1, 3 times x2. The second entry of the vector is the second row of matrix A times the same vector x. So we have 4 times x1 plus 2 times x2. Okay, so this is the basics of matrix multiplication. Now somehow in this lecture only, because of the research community's convention of writing these quantities, they actually, instead of writing a matrix multiplying a vector, they write it as a vector multiplied by a matrix. Now you may say this doesn't even make sense because the vector is, let's say, 2 by 1. The matrix is 2 by 2. You can't multiply 2 by 1 on the right by 2 by 2. Indeed, that's true. So what we need to do is to flip this vector into a row vector. For example, in this case, it will be x1, x2. This is a 1 by 2 row vector times the matrix, which is 1, 3, 4, 2. That's matrix A. Then it's okay, because X transpose with this big T on top is flipping the column vector into a row vector. And now you have 1 by 2 object times 2 by 2 object. And that makes sense because this is 2 and this is 2. The dimensionalities actually match. So in today's lecture, we'll be multiplying the vector pi on the right. So we have to write as pi transpose multiplied by different matrices on the right. This is just an perhaps unfortunate convention of the notation in this specific research community.